We are going to start a new topic called as classification. So far, we built models to predict a number, right? From now on, right, in the classification problem, we will try to um, distinguish between two different categories. Okay, so pictorially, I tried to show something here. Now, so far, what we did was there was some data and we try to fit a line, right? Maybe a straight line or maybe a curvy line or whatever. And we try to fit a straight line or curvy line, and then we made predictions using this line equation. Okay, and then we calculated error and all that. So they are real numbers. So each record is having some value. So we are actually predicting that value using the equation. But from now on, in the classification problem, and in the classification problem, each record belongs to one or the other category. See the y variable values are categories here. Triangle, circle, circle, triangle. So each record, there are some input values, and the output values, are belonging to two categories. This is called as binary class classification problem. Okay, binary means two classes. So only two classes are there. Binary class we call it as binary class classification problem. If we have more than two, we call it as multi-class classification. First we look into binary, and then we look into multi-class and other problems, multi-label and multi-output. So here, right, the parameters x1 and x2, right, input parameters x1 and x2 are in the values are in such a way that there is some distinction between triangles and circles. If we can do a line between these two, right, line can be a straight line or a curvy line again. Okay, here on the regression we were actually drawing a best fit line which may be a straight line or a curvy line. Similarly, in classification also, between two categories, if we can draw a line, below the line one category, above the line another category, right? Like that, if you can now distinguish using a line that is called as decision boundary. Okay, the line which is distinguishing two categories is called as decision boundary. Okay, so if an algorithm can do a decision boundary, then we can use that algorithm to make predictions. A new record comes in, you pass it to the algorithm, and you see whether the outcome is coming less than this line or greater than this line. Okay, based on that we will make a prediction. So this is pictorial representation, but I will show you a data set and more details, and we'll start for discussion. Okay, so give me like maybe 10-15 minutes. Once after explaining a little bit of things, right, some things, so then we'll start for discussion. So there is in a data science project, there is a data preparation step or data collection and curation and preparation step. Okay, so we are taking a data set called as MINIST, right, Modified National Institute of Standards and Technologies. This some institution created this data set. Okay, they call it as MINIST data set. It is image recognition problem in machine learning. Right, it's a small problem, so we are using machine learning. It's a big problem, right? We will use the CN and DN, the deep neural network. So this is a simple example of image processing, and there are some handwritten digits. So somebody wrote 1, somebody wrote 0, somebody wrote 1, somebody wrote 4, somebody wrote 5, right? There are some handwritten digits. The person who collected the data actually took a picture of those handwritten digits. These are pictures of handwritten digits, and the picture should be converted to numbers. So the picture is converted to pixels like this. Okay, step 1, right? And this is like pixels of the picture. I will show you clearly what those numbers are. It looks like all zeros, but there are some dots here. There are around 784 pixels. Each picture is converted to 784 pixels, and then the data is labeled. Okay, this is called as labeling. So I know, right, if I am the one who is creating the data set, I'll take a picture of this, I'll convert that picture into pixels and then label it as 1 because I know that is 1. Right? Somebody wrote 0, I take a picture, I convert it to pixels, then I label it as 0. I take a picture, convert it into pixels, label it as 1. This is called as labeling, right? So in data preparation, you collect data, you convert it into appropriate format and then label it. Okay, we are doing a very extensive labeling activity for one of our client to build a speed detection system. So every day we collect the cars and motorcycles and the number plates, and we'll flag them, we'll label them. I'll show you what is labeling in image processing when we look into the object detection stuff. But we'll label them every day, and weekly once we are actually retraining the model to make the model the best. So this is data preparation step. Okay, we prepare the data, so the data set is there. But here, right, if you look at the labels, there is 1, there is 0, there is 1, there is 4, there is 0, and that is, people can write digits between 0 to 9. So there will be 10 classes in the label. So what I said is we are going to look into binary class problem, right? So we'll convert this data set into a binary class problem by changing the label as true or false. If the record belongs to 5, we'll say true. If the record doesn't belong to 5, we'll say false. So we are converting this data set as a data set to train a model that predicts either 5 or not 5. If you take a picture and pass it to the model will predict either it is a 5 or not 5. We are converting this data set like that because we wanted to see a binary class classification problem. So step by step we'll go. We'll look into binary class first, then we'll look into the multi-class classification problem. Okay. So this labeling task is done, and then we converted the data set into 5s and not 5s. Okay. So if you look at this screenshot, right, there are only not 5s visible here, but in the original data you have 5s also. So there are around 3,795 5 records, and there are 38,205 records belonging to not 5. So there are total 42,000 records. Okay, I'll talk about imbalanced dataset in a moment, right? Once after we know we built a model, I'll talk about imbalanced dataset. So far everything clear? Any questions? Did you get the dataset? Did you understand the dataset? Yes.
Yes, why only 5, not 5?
You can do 8 or not 8, 1 or not 9, 1 or not 1, 0 or not 0, anything you can take. I just took 5 or not 5.
Yeah, that's what. Is there any logic being
No,
taken?
no, no logic, no logic. We wanted to convert this data set into a binary class classification problem. Yeah. Any other
Sir,
question?
regarding pixel, so each and every picture contain 784 pixel, or is it common, or it will vary?
It can vary, but we have tools those with which we can actually constrain the number of pixels to whatever we want. Right? Depending on the camera, the pixels may vary, but we can use some tools to shrink it to the size we want. 784 pixels we want, 784 we can take. 1000 we want, 1000 we can take, like that.
Okay.
But picture quality may get damaged. Some of the pictures quality may get damaged, but overall it works. Okay, so we'll talk about that in deep learning. It's a data distribution problem. Right? We'll talk about that in this, then synthetic data creation and all that concept. Any other questions? Okay, let me jump into the code and show you how to build a classification model. So I have taken this digit recognizer. I already uploaded this data set into the drive, right? I have taken that data set, and then I am looking at the data shape, right? There are 42,000 records and 785 columns. There is one label and 784 pixels. Okay, so I converted the data set into not fives and fives. So when I looked into fives, right, it's a data frame. On data frame, I am doing a filtering, right? Whether it belongs, 5 is a character here, not a number. It is my preference, right? You if you want, you can do it in a different way also. Okay, you can actually directly convert it to true and false. But to make it understandable to you, I actually made it, the 5 and not 5 strings. Okay, so I filtered and looked into the data. I have got 33,795 and 38,000 records belonging to not 5. Okay, not 5 means it can be either 1, it can be 0, it can be 9, it can be 8, any number. Okay, so now I am splitting the data into X and Y. Okay, horizontally splitting, right? Horizontally from all rows from pixel 10 till end. Why pixel 10? Oh, sorry, pixel L0 it is. Pixel 0, right? That is pixel 0 it is, right? So pixel 0 to end. So pixel 1, this label column is the target variable. Okay, you take it. Sorry. So I have taken the label as the Y variable. Now I am splitting data into train test. The first step we are going to do is train test. So the process will not change. The model building process is going to be same, whether it is regression problem or classification problem. The algorithms change, the metrics change. So you remember this diagram, right? We took the data, we splitted the data, right? Then we do feature engineering, we apply algorithm. And this whole process is going to be same. Only algorithm changes and the metrics will change. Okay, so this algorithm part will change, the metrics will change. We'll actually evaluate how the model is working and all that. Those metrics will change. So I splitted the data. Now I took the train data. It is actually 33,600 records. And if you look at the split here, I used a different method. Train test split. Okay, previously I used a shuffle split, right? Now I am using train test split. What train test split does is, it takes the X and Y variables, and here the Y variable has got files and not files, right? So if we know that in total data 37,000 uh, sorry 3,795 records belong to 5, 38,205 records belong to not 5. So when we split the data into 80-20, is it reasonable to split 20% of the not 5s into test set, 20% of 20% of 5s into test set, and 20% of not 5s into test set? Is it reasonable? Is it reasonable to split, take 20 records, so 20% records from 5s into test set and 20% records from not 5 into test set? Is it reasonable?
Yeah, I think it should be.
Yes.
So that is called as stratified sampling. Okay, taking 20% of one class and into taking each class, taking 20% of each class into test set is called as stratified sampling. Can we use the Y variable as the stratifying column? Right, because Y variable is the one which is actually explaining or showing that the record belongs to 5 and not 5, right? So when we use a train test split, that actually does the same way, right? The 20% from the 5s and 20% from not fives it will take and put it into a test set. Got it? Now to distinguish between 20% records, it will use Y value. Got it? No questions, right?
How the X is
Index.
data index. Okay,
Index, X index and Y index are same, right? So for the same record, you will have same index. Even after splitting the data like this, right?
Yeah.
X index and Y index is going to be same. So, from Y it will take 20% and take the indexes and take the same indexes from X. Put it into test set. Again, take 20% from the other set and then do like that. If you have 10 classes also, it's going to do the same thing. Based on Y value, it's going to take this from 20% to test set. Okay. From each class, it will take 20% to test set. Okay. So we splitted the data. Now we are actually trying to look at a particular record. So I would like to show something here. This is for fun, right? This is nothing to do with the model or classification. So I've taken a particular record here, right, with index LOC, and I passed a index. It's a just random index. There is no preference there. And I converted this particular record into, right, this is actually a series object, and then reshaped it into, converted into numpy array, and then reshaped into 28 by 28, and trying to see how it looks like. See that? Does it look like 5? Does it look like 5?
Yes, sir.
Yes, sir.
So when you look at the record, as a flat record like this, right? You don't know what's happening there. All it looks like all zeros, but there are numbers. And when we convert it into 28 by 28, a two-dimensional matrix, only the area, right? The area where the pixels are high is going to have the black color. Okay, so darker color will have the numbers. So when the camera is taking the picture, right, it is actually trying to have pixels where the object is present, and where when the object is not present, is trying to put zeros there, something like that. Okay, or the way the tool is converting it into pixels is trying to convert where the color is there. It is trying to put intensity based on the intensity. See this? In the middle, the stroke is going to be high. When somebody writes, right, in the middle, stroke is going to be high. Edges, the stroke is going to be low. So that the edge numbers are small. The middle numbers are high, big numbers. So the numbers are going to be between 0 and 255 only. When you convert a number into pixels, and the pixel range is between 0 and 255, you call it as grayscale image. Okay, when you take a picture and convert it into pixels and you have only zeros and ones, then you call it as binary image. Okay, right? Grayscale and binary. We'll see color images in deep learning. Now we'll see only grayscale and binary images. So in binary image, right, you will have all these numbers once, okay, wherever the 5 is there, all those numbers are going to be 1, and the rest of the area is going to be zeros and ones. Only zeros and ones will be there in binary image. In a grayscale image, there will be numbers between 0 and 255. Got it? Any questions?
So these pixels are numbers are pixels are.
Yeah, pixels only. These, whatever we see here, I just converted that into a two-dimensional matrix and trying to show you, because the matrix itself is actually showing the number, right? Whatever the number, handwritten digit, it is showing. Got it?
Yes.
So you can actually visually see, how this number looks like. IM show in Matplotlib. There is a method called as IM show. You can pass the number, And C map, binary, we said, it's going to make it as zeros and ones and it's going to plot it. Interpolation, we said nearest. What is interpolation is, there is a 2 and there is a 58. Suppose that there is 63, right? Suppose that this number is not there, this 58 is not there. If we say interpolate, right, what it will do is interpolate linear. What it will do is it will try to take this number and generate this number. Okay, it will try to take this number and generate this number. So that is linear interpolation. I said nearest, right? So it's going to take nearest neighbor, right? Maybe the 63 it will take and put it here, or 2 it will take and put it here, something like that. So when the pixels are missing, how we should actually map it? That is interpolation. Okay, so I am sure we'll take a two-dimensional matrix, right? It takes a square matrix only. We should definitely convert the data into two-dimensional matrix and then specify the C map and then interpolation. Axis half I said because the axis will not come, and it will actually show you the digit there. Okay. So it is for fun. Okay, it's nothing to. Oh my god. So the same way the y variable is also 5. I'm just checking, how the data looks like, input data looks like, and how the output data looks like. For the same index, the y value is 5. For the same index, the input values are like this. Okay. Now we have two classes, right? Like this. Here we have only x1 and x2. We are able to do a plot, right? There are x1 to x784. We'll not be able to do a plot, but just for understanding purposes, you can think like all these fives are down below and not fives are up there, and we should be building a model that actually distinguishes these two classes. It can be a straight line, it can be a curvy line. Okay, so let us jump back. And now we'll see how to build. I have taken one more index, right, and then try to see it is 9. It is 9. Okay. And now I'm going to build a model, logistic regression model. Okay, so this y value is unique and so now right here I'm converting the y value into numbers, integer. Okay, so I took this series object and then there is an apply method on series object and I'm using a lambda function. What lambda function will do? It will take a value x first record value. If it is 1, it will return 1 if it is 5. Okay, if this condition is true, it will return this 1, else it will return 0. So I am actually overwriting the existing fives and not fives. So there is an apply method. How to use apply method I am actually showing here. So a lambda function inside an apply method will actually return the values. You can write a separate function and call it also, but this is more convenient. Okay. So now if you see unique values, right, 0 and 1, I converted the y value to 0 and 1. Okay. Now I am using min-max scalar. We have used standard scalar previously, right, in the SGD regressor. Right? Now I am using SGD classifier. Same stochastic gradient descent algorithm. For classification we are using. How exactly the algorithm works and what are the mechanism, we'll understand maybe Thursday. Okay. So till that point, right, we have to understand many other things. I'll show all those things, and these all things are important for deep learning. From gradient descent till this weekend, this is all gradient descent fundamentals. Sorry, the deep learning fundamentals. Okay. So stay focused, practice, and have questions, come back and ask. Okay. So I have taken min-max scalar and then fit transformed the data Right? Min-max scalar, how it works? It takes the minimum and maximum from each column. Right? There are 784 pixels. First pixel it takes minimum and maximum, subtracts minimum divided by maximum minus minimum, subtracts minimum divided by maximum. Like that, every column it takes maximum and minimum and applies. When you say fit, it finds out the maximums and minimums of all the columns, keeps them aside. When you say transform, that's when it actually applies the transformation. So now we applied scaling because as gradient descent algorithm needs a scaled data. Can I can do other kind of scaling also. Maybe take maximum and divide, right? Maximum divide the columns. That also can be done. Okay. So I took the SGD classifier. This SGD classifier is using logistic regression. The algorithm name is logistic regression. Linear regression is for regression problems. Logistic regression is for classification problems. Okay, logistic regression will predict either true or false, or 0 or 1. It will not give you a real number. So logistic regression algorithm is used for classification. So SGD classifier is implements logistic regression algorithm. There is a class called logistic regression also. Okay, you can use that, but logistic regression class will use normal equation, not the stochastic gradient descent algorithm. Okay, so I have taken the SGD classifier and I set random state and I specified log loss. There is a hinge loss and log loss, two kinds of functions. We'll focus majorly on log loss. I'll show you what is the function and all that, maybe tomorrow's class. So I fitted the model. Right now I am trying to check the accuracy of the model. Right, once after fitting the model we can predict. Right, see this SGD classifier dot predict of the trained data. So you take the data, you split the data, right? You then do the pre-processing. There is no pre-processing needed here because the data set is clean. Okay, so I have taken the data, no pre-processing. I applied algorithm. Now I am checking the model, how the model is working by passing the input data. Right, only x's I will pass. Right, see this here. I passed x's and predicted. Actual y value is here, and already we have it in the target variable, and the predicted values are here, and I am using accuracy score, a method called as accuracy score that shows that 97% accuracy. Okay, the model is working good so far, right? It looks like model is working good. I will not say model is working good. It looks like model is working good. Now on test set we need to test it. So I have taken test data, transformed it using min-max scalar because we did transformation of data and then applied the model, right? Then fitted the model. So you should pass the data in same format as we passed it while training. So I transformed the extrained data, and then I converted the target variable into ones and zeros. All the transformations we should apply, and then I am again checking the accuracy by predicting by passing the test set data. Okay, these are all predictions, and this is actual y, and we are calling this accuracy score to look at it. So it looks like 97%. It looks like model is balanced and working well, right? It looks like that. So any questions so far? We'll look into the accuracy measure and how exactly this accuracy measure is calculating, and I am saying it looks like even though it is showing 97% both on both, right? Any questions so far?
Why have we converted that 5 and not 5 into zeros and 1? Is it to convert into numericals before applying the model?
Yeah, numerical, the logistic regression, the scikit-learn and TensorFlow, PyTorch, these modules expect data in numerical format. Either it is input or output. Or true or false also you can pass. Boolean values also you can pass. The module expectation we are trying to satisfy. Any other questions? Okay, so we built a model, right? We built a classification model, binary class classification model, and we predicted, we calculated accuracy also. But here, what I'm saying is, this looks like working good. I'm not saying it is working good. There is a reason. So here we have got accuracy 95% on train and 97% on train and 97% on test. The score may be misleading as dataset is imbalanced. On a classification problem, you should be very watchful about whether the dataset is balanced or imbalanced. I'll talk about that. Accuracy is not a good metric to measure performance on an imbalanced dataset. When I say, well, no, what I mean by imbalanced dataset, if you look at the data here, there are around 3,700 records belonging to 5 and 38,000 records belonging to not 5. That is called as imbalance. Class 1, right? Class 5, there are 3,700 records. Not 5, not belonging to 5, there are 38,000 records. So this kind of data set is called as imbalanced data set. So the records belonging to one class and the other class are completely of different size, right? Then we call it as imbalanced data set. So if you look at this example, so now this is the data x0, x1, x2 and so on. Xn is the data and y is the target variable. So if you look at this, right, 90% of the data belongs to 0 and 10% data belongs to 1. This is an imbalanced data set. Are we in the same situation in our data set also? 90% belongs to one class and 10% belongs to another class? Here also.
Yeah, almost.
Right? Almost, yeah. More than 90% is
90%.
belonging to not 5 and maybe around 9.5, 9.7% belong to 5 approximately. Right? So we are in the same situation. That is called as imbalanced data set. So if you see this here, on this 10 record data, so there are 10 records here. We don't care what X is, but Y, right? There are 9 zeros and 1 1. And I have built a model that predicts all zeros here. Okay, all zeros. So what is accuracy score? The accuracy score method, accuracy score function we used is doing some calculation, right? Some math to calculate the accuracy, right? So what is that calculation? That calculation is this one. Count of correctly predicted divided by total records. So if you look at this, how many are correctly predicted? How many are correctly predicted?
9.
9, right? How many total? 10. It is 90% accuracy it is showing. But if you pass 10 more records, right? 10 more records with 1, model will predict 0 only. Because model doesn't know, it's a dumb model which actually predicts 0 for every record. It did not capture the pattern properly, but still it looks like 90% accuracy. Got it? The accuracy, the measure accuracy metric is misleading when data is imbalanced. Got it? The point I am trying to make here is, you built a model that is good, but how to check the accuracy is also important. There are different metrics like accuracy score, F1 score, precision, recall, AUC curve, ROC curve, AUC score, ROC curve, precision recall curve. So these are all different metrics. Which one to use where, we should know in a classification.
These are all metrics for only the classification problem?
Yes, yes. So we are going to understand one after the other slowly. Okay. So here I am trying to show you the problem with accuracy score. There are some articles where people actually build models on an imbalanced dataset and try to show accuracy as the metric, saying that the model is working good. That is completely wrong. So they are bluffing actually. Okay. So if our model is also maybe working like this, we don't know, right? It may be predicting most of them zeros and very less numbers ones, and then it is showing 97%. But in production data, if you get most of them fives, right, for pictures of fives, the model will not predict correctly. Okay, so not just building a model, checking the model's accuracy is also important. So any questions here? Imbalanced data and accuracy measure. Accuracy score is not a good metric to check whether model is working good or not. Any questions?
So for this example, we have actually taken 5 or not 5 just to show the binary.
Ah,
And yeah, I think this data set can also be converted as a balanced when we say less than 5 and greater than 5 kind of stuff. So in that case, the data set will be balanced.
yeah. Then we can actually, we can use accuracy metric, accuracy measure as accuracy score as a metric.
Okay.
Yeah, that's a good understanding. Yes.
Thank you.
Yeah. So, right, here, right, we have that flexibility in this particular data set. We have that flexibility to convert the data set into a balanced or imbalanced. But in real time, right, you will get a data set with imbalanced data, then you don't know what to do. So that's where I created imbalanced scenario and trying to explain. Okay. So now, right, if imbalance this accuracy score is not right, then how should we actually measure, right? How should we actually measure? The confusion matrix is a metric which actually shows you how exactly the predictions happened. Okay, let me show you what is confusion matrix and now what it exactly explains. So this is a bit confusing. Confusion matrix itself, the name itself is a confusing thing. So in our accuracy score, right, records belonging to one as positive. So notation, right? So here we are thinking of positive records and negative records. So records belonging to one are called as positive records. Records belonging to zero are called as negative records. Okay. So here in the accuracy score, it is just trying to see how many are correctly predicted. Right? But when you clearly look at the problem, right, how many positive classes are predicted as positive, how many negative classes are predicted as negative, how many positives wrongly predicted as negative, how many negatives are wrongly predicted as positive. So four scenarios are there, right? If you try to look at the counts of the records, there are four different kinds of counts are there, but it is actually looking into only one kind. How many are correctly predicted? Okay, or maybe two kinds. How many correctly predicted or wrongly predicted? Right, only two it is looking at, but there are four categories. The confusion matrix actually looks into four of them. So if you look at this diagram, actuals are rows and predictions are columns. Okay, so if you count that row, right, the highlighted row, you will get total number of actual negative records, not 5 records in the data set. Right, there will be some number here, some number here. If you count, if you sum those two numbers together, you will get not 5s in the data set. Okay, let me show you that here. See this? This is a confusion matrix. So there is a method called as confusion matrix in scikit-learn metrics module. Confusion matrix takes the actual y and the predicted y. Okay, actual y and predicted y it takes confusion matrix, and the matrix is a numpy array. Okay, there are two rows there, right? First row And that highlighted part is all positive records. Sorry, negative records. Negative records means not fives, right? If you sum these two numbers, right, total number of not fives in the train set will come. This total is all positive records in the data set. Okay, so that is rows of the confusion matrix. Rows of the confusion matrix. So now that part is clear, right? Rows of the confusion matrix, that part is clear, right? Any questions? If you look at the confusion matrix, the rows specify the existing data in the actual data in the data set. How many records belonging to negative? How many records belonging to positive? Okay. If you look at column, right, how many are predicted negative, right? How many are predicted negative? So there will be predictions that made, for the negative record as negative, positive record as negative, right? Wrongly, it would have predicted some positive records as negative. 701 records, which are positive, were predicted wrongly as negative. Okay, so this column wise, if you look at, right, the column wise it shows how many are predicted negative or positive, right? Predictions count it is. Columns are the predictions count, rows are the actual count, right? On the positives, how many positive predictions, right? uh, if you look at this row, the total is belonging to the negative records, but out of those negative records, not 5 records, 174 records are predicted as positive. And if you look at this row, these are all positive records, the counts, right? And out of the positive records, 2321 records are predicted correctly as positive. So this number and this number shows negative records correctly predicted as negative, positive records correctly predicted as positive. This number shows positive records predicted as negative. This number shows negative records predicted as positive. So that is confusion matrix. All four scenarios are considered and the counts were taken. If you look at accuracy score, we are taking counts on the numerator and denominator. But the counts are considered, only two category counts are considered. That is correct or not, which is not considering positive correctly predicted positive or negative correctly predicted as negative. Because on an imbalanced data set, if you look at this imbalanced data set, this record is more important. That record belonging to the one is more important, right? If the model is correctly predicting this record, minority class we call it as, then model is actually understood pattern. If the model is ignoring this pattern, right, it is not understanding the pattern correctly. That's the analogy, right? The basic analogy is that whether model is understanding the pattern correctly or not, it can be judged by looking at the minority class and how it is being predicted. So to know that how many positives are there, how many are correctly predicted, how many negatives are there, how many correctly predicted, how many positives are negatively wrongly predicted, how many negatives are positively wrongly predicted, we should know all four categories. All four counts will come in confusion matrix. Any questions here?
So this is only for the binary, sir?
No, even for the multi-class also will have, and I will show you. Multi-class confusion matrix is going to be very confusing. I'll show you.
This example is only for binary, correct?
This example is for binary. Let us solidify the concept and understand and become strong, and then we look into the multi-class. So you understood, right? So the rows and columns of the confusion matrix you understood, right?
Yes.
Yeah. Good. So here there is a very confusing terminology again, right? The true negatives, right? Truly they are negatives. This count, whatever is shown here, is truly negatives. Right? True negatives are after model built and it is predicting. true negatives, right? The model understood them as negatives and they are negatives, true negatives. They are negatives really. The records are negatives. And the model also understood negative. That is called as true negatives. So this is true negatives and this is true positives. Okay. So the model, actually they are positive and model also understood them as positive. So they are true positives. Okay. False positive. Actually they are negative, but our model understood them as positive. False positive. Falsely understood as positive. Okay. And then is here false negative. The model understood them falsely as negative. Model understood. Model is the perspective. You need to look into confusion matrix, from model's perspective. Model true negative. Model truly understood as negative. Model truly understood as positive. Model falsely understood as positive. Model falsely understood as negative. Okay. Actually they are positive. Falsely understood as negative. Actually they are negative. Falsely understood as positive. How am I saying? Always, when you use scikit-learn's confusion matrix method, this is the structure. Is there a guarantee that the same structure is followed in other modules? You don't know. Now other modules may consider positives as first row, negatives as second row, positives as first column and negatives as second column. It depends on the API. Got it? Scikit-learn uses this structure. Right? If you look at confusion matrix in the internet, you will see positives in the first row and positives in the first column. They may have looked into something else, some other module. The module's implementation is important. Got it? Got it?
So what do you mean by some other module in this case?
Maybe R language, maybe Veka, maybe H2O. Right? If you look at confusion matrix, so these guys have given as me. But, some images will be there which will take positives. See this? See, this guy actually took positive as the first one, negative as the second one, positive as first one, and negative. So this is like, maybe they are looking into some other API, and that API actually is using our, producing the output as like this. Got it?
So the other API is an alternative for sklearn?
Yeah, there are alternatives only. R language, the Veka, the H2O. H2O is actually using deep learning, I think, deep learning framework, I think. I haven't seen it. Right? So these are all other alternatives. But Python is the best, yeah, as of now, because it's got the PyTorch and TensorFlow deep learning modules. H2O is actually picking up a lot of steam. But once we know the concepts, right, it's not a big deal to learn a new language. Got it, right? Don't get confused. Some people used to come back and say, right, somebody used to positive here, why are you showing negative? The scikit-learn I am following, the scikit-learn's output I am trying to explain. So I am showing the confusion matrix in the scikit-learn format. Okay? So that is confusion matrix. Now we will actually calculate scores called as precision and recall score. Okay? So let us go back and try to understand. So in this particular example, right? So not 5 is classified as not 5, 5 classified as 5, not 5 classified as 5, this much count, 5 is classified as not 5, this much count. If you look at this confusion matrix, right, you will get complete clarity. Okay, now we need to look into the other metric. So accuracy score we said is not right. Generally, we always use it to look at one score and say whether model is working good or not. Okay, but when you look at confusion matrix, you have some clarity, but you don't know whether model is working good or not. Right? So to do that, we have to calculate precision and recall, two scores. We will come down to one score in a moment, but we need to look into precision and recall. What is precision? The total number of positive predictions divided by, sorry, the total number of positive, sorry, the total number of, sorry, total positive predictions, correct predictions divided by total number of positive predictions. Okay, out of total positive predictions, how many are correct? Out of total positive predictions, how many are correct? What are total positive predictions here? What are total positive predictions here? How many?
2320.
No. Total positive predictions.
Plus 134.
Plus 134. 2320 plus 134. Right? These are all positive predictions only. It's a confusion matrix. Then they named it very right. So no, after the class, right, go through it and you'll get more clarity, right? So total positive predictions are 2320 plus 134. Out of this, right, how many are correct? 2320 only correct. This is wrong, right? They are negative records predicted as positive, right? So out of total positive predictions, how many are correct? So to do that, right, this divided by these two sum. Okay. So true positive divided by true positive plus false positives. Out of total positive predictions, how many are correct is the precision. So, if somebody is doing with 100% precision, work with 100% precision, what that means? Whatever he does is all right. Right? 90% precision means, 10 tasks you give, 9 he will do correctly and 1, he'll not do it correctly. Right? So that is precision. Okay? Recall. There is another score called as recall. Out of existing total positive records in the data set, how many are predicted correctly? Recall, out of existing total positive records in the data set, how many are there? Existing total positive records in the data set?
2320.
2320 plus 702. And this whole thing is existing positive records, right? In the data set, they're all 5. They're all belonging to 5. But model predicted 702 as negative and 2320 as positive. Getting it?
Yes, sir.
Right? Yeah. Now I think you have more clarity. So there are real 5s in the data. There are predicted 5s. But there will be difference between real 5s and the predicted 5s. So we are trying to see how, where exactly the mismatch is happening, right? How much count is mismatch, right? Not matching properly, right? So the 5s, we have, out of total existing positive 5 records in the data set, how many are correctly predicted? So it's going to be 2320 divided by 2320 plus 702. Okay, so our precision is 94%, recall is 76%. Okay, precision is 94% and recall is 76%. Okay, so what is it actually trying to explain you is, the precision and recall scores are basically focusing on positive records only, right? In here, right, I said that in these 10 records, if model is understanding properly about the minority class record, then model is working good. I said, right? Right? Do you remember that? If the model is understanding or making prediction on the minority class record, then model understood, the data pattern properly. So that's what we are checking here. If you look at precision and recall scores, the focus is on the minority records. What are minority records? 5 records are minority, right? In this particular data, right? Do you agree?
Can you repeat, sir?
So, if you look at the scores calculated here, either precision or recall, what is the major focus there? Existing positive records, how many correctly predicted? Predicted positive records, how many are correct? It's all about positive records only, positive predictions and positive records, right? In this data set, the positive records are lesser. It's a minority class, right? So these scores are high, right? If this is 99% and this is also 99%, then I can say the model understood correctly. The model understood the pattern correctly. Does it make sense? Does my statements make sense? Yes, no.
Yep, yep.
Right? Our focus or the model's focus should be on the minority class, because understanding pattern on the minority class is difficult. When you are training a model, the data should be high. When I say data should be high, the volume of the data, number of records should be high. For all different classes, the data should be high. In a given data set, for a particular class, the data set size is low. That means the understanding pattern in that low, less amount of data is going to be difficult for the algorithm. And algorithm, we built a model, right? We built a model and trying to check whether algorithm understood well or not. So how will we check whether it understood well or not? You should actually check the minority class predictions happen properly or not. If the minority class predictions happen properly, the scores are coming high, that means model understood properly. The model will work better in the production or test. Rather, it will not work. So precision and recall gives you that kind of perspective, right? It actually shows you how the model is working on the data, on the minority class data. The precision and recall's focus is on minority class only. One direction is prediction. How many positive predictions are correct? Right? Total positive predictions. Out of total positive predictions, how many are correct? Out of total existing positive records, how many positive? How many correct? Right? Out of total existing positive records, how many are correct? Out of total positive predictions, how many are correct? Both ways we are looking into positives only, right? If this score is zero, this score is zero, how much precision and recall will come? If this score is zero, this score is zero. 100. Both precision recall, both will come 100. That means all the positive records correctly predicted, right? All the positive predictions are correct. Positive predictions are correct, right? Positive predictions are correct. Positive records are correctly predicted. Okay? Predictions perspective, existing records perspective, right? Existing positive records perspective. So accuracy score is not right. Even though the model is predicting all zeros, it is saying, right, it's a good model. But if you try to calculate, precision recall for this particular data set, right? Let us try to calculate that. Let us try to do a confusion matrix for this.
Just 1 second, sir. So
yeah, please.
Just to reiterate, the first of all, identification of the minority class is based on the actual output value. That's based on the actual output value. Whichever is less, that is considered a minority class.
Yes, sir. Very good point, sir. Yes, very good point.
That's important to first understand.
Yes. I am about to come to that. If you, right, some people will take it like this. I know, maybe I'll talk about it. That's a very good point, and you already captured it, right? I'll come to that. While labeling the data, one should be aware that minority class should be given 1. It doesn't matter how business says, what business says, it doesn't matter. But minority class record should be given 1. Majority class should be given 0. Right? That point is very important. Okay. So you already captured it, and I'll explain that. But let us try to do a confusion matrix for this particular data set. Right, this is actual. This is predicted. Okay, pred I will put. Okay, and then this is negative. This is negative. This is positive. This is positive. Right. So now, what is the count here? How many negatives are predicted negative? How many negatives are predicted negative? There are 10 records in this.
9.
Everybody agrees? 9?
Yes, sir.
Yes. Good. So how many positives predicted positive?
0.
0. Right? That is count. Okay. And then how many negatives predicted as positive?
1.
Negatives predicted as
Sorry.
positive.
0.
0.
0. How many positives predicted as negative?
This is 1.
1.
1. Right? Now if you calculate the precision score, right? Precision. What is precision? This direction you need to look into. Okay. What is precision? Out of total positive predictions, how many are correct? Right? So total positive predictions are 0. So total positive predictions are 0 plus 0. Correct predictions are 0. 0 divided by 0 plus 0. 0. Okay. Recall. Out of existing positive records, how many are correctly predicted? Existing positive records, 1, right? 1 plus 0 is the denominator. How many are correctly predicted? 0 is the numerator. 0. See this, the model is not working at all. When you look at accuracy score, it looks like 90% accuracy. But when you look at precision and recall, it is showing the clear picture. Got it? Got it? Precision 0, recall 0. That means model is not working. Not working at all. Got it? Clear? Any questions? Yes, no?
So in that case, where we are going to use that accuracy?
Accuracy, balanced data sets only.
Only
Balanced data
balanced
set means
data set.
maybe 40-60, no, maybe around 70-30, maybe 40-60. 50-50, 40-60 kind of data sets are there, then you will be using accuracy score.
Okay.
Any other questions? So the precision recall scores are clearly showing you whether model is working good or not. Accuracy score is actually misleading you, especially when the data set is imbalanced. Imbalanced data set problems are the problems in the industry, and we should definitely understand this. Rather, we'll build a model and we'll think the model is working good by looking at the accuracy score. It's a mistake. So which metric should be used for which kind of problem should be known. Okay, that is very important. Okay, this point is clear, right? So let me move on and show you a metric called as F1 score. So here, right, we are actually looking into two numbers, right? Two numbers, and one is actually small and one is big. We don't know, right? If you are building two models, right, one logistic regression, another random forest. One gives a 74% precision, 76% precision, and 94% recall. Another gives 94% precision and 74%. So other way around, right? You will get confused. What to do, you don't know. So we are trying to consolidate these two numbers and create one score called as F1 score. Okay, F1 score, F score, or F1 score. Okay, so here you can actually take average, but when you take average, right, there will be undesired results there. Let me show you. Suppose that for a model the precision is 90%, right? 0.9, and recall is 0.10, no, 10%. Okay, only 10%, right? If you take average, right, what happens? 0.9 plus 0.1 divided by 2 is going to be 0.5, right? Average score is going to be 0.5%. It looks like it is okay, but model may not be working well. When I say 10%, right? Existing positive records, only 10% records model predicted correctly. Maybe 90% of the predictions, positive predictions, are correct. But if you look at in the data set perspective, existing data, 90, there are maybe 1,000 records, only 10 records for correctly predicted, right? That is not right, but it is showing that 50%, right? So the average, taking average is not right. So F1 score actually takes like this: 2 divided by 1 by precision plus 1 by recall. Okay, so this is precision, PRECA. So precision and 1 by recall. So this is called as harmonic mean. What it does is, one of the scores is low, right? This 10% is very low, 90% is very high. So when you calculate using this formula, the total score comes down to this score. Let me try to calculate and show you, right? So 2 by 1 by 0.1 plus 1 by 0.9, right? What is 1 by 0.9? 10 by 100, right? This is 100 by 10. This is 90 by, sorry, 100 by 90, right? Do you agree? Do you agree? Do you agree? Should I show you clearly?
Recall, why it will be 100 by 90? That 1 by recall, it's a.
Let me show you. So 2 by 1 by 0.1 plus 1 by 0.9, right, is going to be 2 by 1 by 10 by 100 plus 1 by 90 by 100, right? Right? So now you flip it, right? It's a 1 by whatever, you flip it and it becomes 100 by 10. This is also 100 by 90. Right? Now you can cancel this, and now, right, it is 10 plus 10 by 9. 10 plus 10 by 9. It is going to 2 by 10 plus 10 by 9. And now you try to do this 90 plus 10, right? It's going to be 90 plus 10, sorry, 2 by 90 plus 10 divided by 9. So if this 9 goes upright, it's going to be 18, right? This denominator is going to be 100. 18 by 100 is going to be 0.18. What happened? Even though the score is high, it actually came down after calculating using this formula. After calculation, I've got 0.18. That means it came down to this 0.1 score. So when you use this harmonic mean formula, this is called as harmonic mean or F1 score, it actually pulls down the total score to the lowest score, whatever. Okay, that way, see, we are trying to see whether model is working good or not. It always should show. It is, if it is not working good, right, it should show. So here it is actually showing it, right? That's where F1 score is used to compare multiple models. Got it? Got it?
Yes, sir.
Right, that is F1 score. Okay, so we have covered confusion matrix, the precision recall score, F1 score, right? On our data set also we calculate F1 score. It is showing 84%. Okay, so this is the actual score, right? Let me try to show one more point. Actually, Girigaru already highlighted it. So let me try to. So this is right. So I made one statement, right? Always minority class should be given 1. Okay, majority class should be given 0. Okay, whenever you are creating a labeled data set, minority class should be given 1, majority class should be given 0. Rather, the precision and recall also will mislead you. I am making a statement now. If you don't give proper labeling, what is proper labeling? Minority class should be given 1, majority class should be given 0. If you don't give that way, the model, the precision recall score will also mislead you. Let me show you that. Okay, let me try to take another screenshot of this particular screen and then show you. So this is very important. This is very important. Irrespective of business, you should be giving minority class 1 and majority class 0. Rather, your precision recall score will mislead you. Suppose that, right? Suppose that I have given the majority class 1. Okay. Okay, and minority class 0, right? And the predictions are also like this. The predictions are all 1. And I am changing this data set. Okay. Suppose that I predicted all 1s, not zeros, all 1s. Right? Majority class I gave 1 and minority class I gave 0 in the actual Y. Right? When I predicted, right, I predicted all 1s, not zeros, all 1s. Now accuracy score, is it 90%? Accuracy score 90%?
Yes.
Right? So that it didn't change. Right? Now let us try to do a confusion matrix and try to calculate precision and recall scores. Okay? So this is negative, this is positive, this is negative, this is positive. These are predictions, these are actuals. Okay? So how many negatives predicted negatively? How many negatives predicted? 0. How many negatives predicted positively?
1.
1.
How many positives predicted negatively?
0.
How many positives predicted positively?
9.
9.
Let me try to calculate precision. What is precision here? You should tell me.
1 by 1 plus 9.
1 by 1
9
plus
by
9.
9 by 9 plus 1.
9 by
10.
10.
This is this is what you need to look at, right?
Yes, yes,
So,
yes.
right, out of total positive predictions, how many are correct? So 9 by 10, 90%, right? Recall, how many? What is recall? This direction.
9 by 9 is 100%.
9 by 9 plus 0. Right? 9 by 9 plus 0. Total positive records are 9 and predicted 9 correctly, 100%. See this? Is the model working good? Minority class, is it predicting? Is the model working good? Huh?
No.
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 But metrics are showing that it is working good. Right? Got it? Metrics are misleading you. Right? Like accuracy score, metrics are misleading you. Why it happened? Because of labeling, wrong labeling. Got it?
Is there any other metric, even if we label wrongly, is there any other metric which shows?
No other metric, no other metric. Only these metrics, and we should properly label the data. We understand mechanics, then we'll use the tool appropriately. It is like bike. You have a bike and you need to kickstart it. Only then it starts. You tilt it, twist it, it's not going to start. Like that, we need to understand mechanics and use it. No other metrics are there.
Okay.
Got it? So this is a very key important point, right? After you executed maybe 5-10 projects, right, you will get it. Okay. So this is a very important point you should remember. Minority class should be given 1 while labeling. Then only your metric will show you appropriate results. Okay. Right? Precision recall also will not work if your labeling is not right. If labeling is right, then only precision recall will work and properly show you the results. That's where in our data set I have given for the 5 records I have given 1 and not 5 records I have given. Now if you look at this alpha, the lambda method, the y value belongs to 5, I gave 1. If not, I gave 0. Okay, that's an intentional one. So that's it for today. Any questions you can ask. Any questions? These classes are very important and people are missing. Not initially, maybe. I don't know. Any questions you can ask. Okay.